Assalamu alaikum. I am Abid Ibn Saif and this is the demo for our machine learning project. Um, Before we start, we did the project in three different steps. In one step, we did the ADA, exploratory data analysis. In another step, we build our model using only 5 epochs. And in another set, we build our model using 15 epochs. Uh, so at first, we already run this code for the simplicity and for the time saving. So we already pre-install all these libraries. So we are using Google Colab, and this pre-processing was done by brother Hanif. So what he uses is he load the data from the dataset, train and testing dataset, which we collect from UCI machine learning repository. Then he level them, and that is the first few only 5 rows of the dataset. So then we go for the exploratory data analysis. As it mentioned here, this dataset contains 564 columns, and we can easily spot out that many columns contain same stem. So what brother Hanif did is he grouped them together like this, and because we are doing human activity recognition using smartphone data, mainly there are acceleration and gyroscope feature, and there were few gravity feature as well, which were then removed from the dataset. Then we checked for our missing value, as it was keep well maintained by the uploader. There was no missing values in the dataset. Then we are finding out the number of observation for each class. Then we are going for our EDA plot. So what we did was we tried to understand that our activity is differentiable. For example, in this EDA, we can see that using the clustering method, the laying is in one cluster, the groups are in, the formation of them is totally different from each other, although there are some variances and overlapping between them. And so it can be seen that those are easily identifiable, those activities are easily identifiable. Now after performing EDA, we were ready to build our model. So we used the framework Keras. So this was also done by brother Hanif. He did the he built the model with 5 epochs, and he import pandas to and numpy to do uh, so basically he import pandas, numpy and matplotlib to do some calculation and storing the data as well. So for example, here he is loading a single file as a numpy array, so that's why he had to load the numpy. So in this section, what brother Hanif did was, in our dataset we had different text file containing the same set of data. So what he did was he combined all of them together so that we have a single dataset. So after combining all of them together, if we look at our shape, we can see that our train X and train Y shape is already given here. Our train X shape is this one, train Y shape is this one, and following so on and so on. Then he created a simple RNN model using these values, passing into this function. So in the verbose, what he did was, verbose is basically showing the calculation for all the epoch. So he set that as 0. So in future, when he ran his code, so there were no uh, result showing that in each epoch how many accuracy was obtained. So again, I said that he was using 5 epochs to build a model. So he used the epoch as 5 and batch size was 64. Then he used number of time step as train x dot shape 1, which would be 128. Then he used the number of feature as train x dot shape, which would be the 9 feature we got from our data preprocessing, and number of output would be train y dot shape, which is this one, 6. So basically we have 6 activities, so that's why we have 6 categorical outcome. So in this section, brother Hanif did was he made this into categories, and now we are going for our model. So in Keras we have to write this model equal to sequential. Now this one is our input state model dot add equal to simple RNN. There are 100 layers. Return sequence tree and input shape is train x dot shape 1 and train x dot shape 2, which is basically number of time step and number of features. Then we use the four stacked RNN. And then we applied dropout as 0.5. Basically what dropout is, it is a regularization function. So what it does is it achieves it makes sure that our data is not underfitted or overfitted. So then we use a dense layer with 100 nodes, and the activation function would be rectified linear unit. And then we use another output layer, which in the end the activation function is softmax. So softmax function is basically will give us values between 0 and 1. So at the end we use the model.compile, and loss is as categorical cross entropy. So it will give us in using categorical cross entropy we can easily make sure that our output is in categories. And optimizer as ADAM. So the full form of ADAM is adaptive moment estimation. So we know about stochastic gradient descent. What stochastic gradient descent does is stochastic gradient descent maintain a single parameter for learning rate for the whole epoch, for the whole training set. And ADAM is actually combination of adaptive I forgot the name, RMS prop and AdaGrade, the combination of RMS prop and AdaGrade. So both of them are improved version of stochastic gradient descent. So using ADAM we can in single epoch, after the training on the single epoch, we can change our learning rate using ADAM. So at the end we want our metrics as accuracy. So then we fit our dataset using train X and train Y, and then we evaluate our dataset on test X and test Y, and we return our accuracy and model. So here we are running the experiment. So in here, to get the score in more literal form, we are multiplying with 100, and when run the model, so it gives us this following output, and the RNN model score is 59.179 using only 5 epoch. And the total parameter that was trained during the weight and biases was updated is 2106. So for the LSTM we decided to keep the same model as RNN, just using the LSTM function, and all of the rest are same, so that we can compare between both of them and see which model performs better. Similarly, our run LSTM experiment is also same. So after running the model, we get our model score in 71.463%, and the total parameter that was trained is more than RNN, is 376,306. So after that, what brother Hanif was trying to do, he did a precision recall F1 and uh, build a confusion matrix, and from that he used the kappa score as well. So if we go for the result, we can see that RNN precision is around 59%, recall is around 56%, and the F1 score, which is the extended version of precision, extended output of precision and recall is basically 2 times multiply of precision and recall and divided by precision plus recall. So what it does is the F1 score is around 52% and the Cohen kappa is around 50%. So we can, from here we can see that the model performed badly. And for the RNN confusion matrix, Brother Hanif didn't write the level, but one is for laying, this one is for sitting, this one is for standing. But we can see that in the walking upstairs column, yeah, there are not many incidents which he can identify. Instead of walking downstairs, he classified all of them as walking upstairs, walking downstairs, and walking. So in the case of LSTM, the model improves a little bit, but not that much. So from this section, we can say that using only 5 epoch is not suitable for our code, because it is giving us if we evaluate the confusion matrix, it is giving us bad result, and also the precision, recall, and all the other things are not as good as it should be. So before moving to the coding for epoch with 15 epochs, I wanted to mention our work distribution. So Brother Hanif did the coding for EDA and RNN with RNN LSTM with 5 epochs. Brother Ahmad and Noman did this code, which is RNN LSTM with 15 epochs. I am Abid. I did the report and the voice recording of this video and the presentation slide, and this is it. So in order to keep both of our model and evaluation as competitive and justified, so we didn't change all the other thing. What we change is we only change the number of epochs and we add some more evaluation technique. So if you can see that all of these are similar like the one I showed before, all the data collection, and the only change occur in this code is this one, and the following are some of the evaluation measures. So we increase the epoch here as 15 and all of the rest are similar. Just brother Noman, brother Mahfuz add MSE instead of in previous example it was only accuracy. So instead of matrix he wanted to see mean square error as well. So when he run the model, it can be seen that he got accuracy around 62.8% and his RMSE of RNN model is 0.27%. So if we go into his confusion matrix, and the model can predict laying, sitting, and standing correctly as we mentioned in our presentation slide as well, but the problem arises when the model tries to differentiate between walking upstairs and walking downstairs. Even in this scenario you can see that in the standing, the standing is, if you combine all of this and divide the summation with 420, it can be seen that even the standing is not that accurate. So what brother Ahmad and brother Noman did is they tried to find out why this is happening. So using this graph we can see that in this section we have the loss or accuracy values, in this section we have number of epochs. So as the number of epochs are increasing during the RNN with 15 epochs, so we can see that the accuracy was started to climb until epoch number 3, then it started to drop and it continued with around 60%, and at the end it dropped pretty low. But the main issue occurs when this is the train loss, the blue line. So you can see that after the third epoch, the loss is continue to rise steadily. So from here we can understand that because of the incapability of RNN to go to the trace back, so he is losing data fast and losing the accuracy as well. In the next step, he wanted to find out the precision, recall as well, and F1 score as well. So we can see that our precision for laying is quite high. Sitting is also acceptable, but the standing precision is quite poor. Even the recall is acceptable, but the F1 score is pretty poor as well. And the rest three, walking downstairs and walking upstairs, is pretty bad. Even walking downstairs, there is not even single case identified that this event would be walking downstairs. So that's why it was missing from here in the graph. So if we sum them up, it will give pretty bad result because of there is no activities identified as walking downstairs, and the mean average would be around 56%. Now we are using all of this code as running, because if we run all of this code, it takes at least 20 to 25 minutes to get all the values. So that's why it was we are just planning on the given result is there. We will attach the IPython code as well as the Python code in the submission folder. So here brother Noman and Ahmad tried to find out the ROC curve. So from the ROC curve we can see that our area under curve would be around 70%, approximately 70%. Sorry, my mistake, as it is saying here that ROC curve area is 93%. So this is just the stage we printed out, that what we did after our input. These were all the 4 stacked RNN, then the dropout layer was applied, then the dense layer and the output layer. So here we build the LSTM model with 15 epoch as well, and all the rest were same. Now if we come to the model score, it scored around 84.22%, and the RMSE was 0.18%. If you see from above, it is lower than RNN. The RMSE for RNN was 0.277%. So RMSE is another evaluation matrix. We can say that if the RMSE is low for LSTM, that means it is performing better than RNN. Let's look into the confusion matrix. So in this scenario, the laying activity was recognized well. Only the problem around it was when it performed moderately was the standing. So after we go down, so from the confusion matrix we can say that our model performed as expected, but there are some areas to improve as well. So similarly, if we want to plot the graph from RNN, which we did in RNN, so we can see that why LSTM model perform better is from the beginning, as the epoch is increasing, the train losses is going down, and as the epoch is increasing, the train accuracy is climbing steadier. So that's why the LSTM model perform much better than the RNN. Similarly, if we look at the precision, recall and F1 score, we can see that for all of the activity the model performed pretty well. Only the value under 79, under 80 was the standing. So that's why the average of this model was around 90%. The precision, recall and F1 score all become pretty similar. Now if we plot the ROC curve, it is saying that the area under curve is 98%, so it's probably it means that 98% of the activity is properly recognized. And if we go further, it is just our LSTM model. So from these performance metrics, we can say that our LSTM model perform much better than the RNN. And this was our code demo. Thank you very much. Assalamu alaikum.